So now the next part of the question requires us to find the number of y12. The number of y12. The number of y12. Number of y12 required for the slab. So now, from the diagram I showed you before, we need two types of reinforcement: the main bar and the distribution bar. So now, the main bar actually runs on the longer length, but uses the shorter side of the slab as its basis. The distribution bar runs on the shorter length, but uses the longer length as its basis. So now I'm going to show you that. I'm going to show you the diagram for the. I'm going to show you what I mean exactly. So now this is what I mean. This is all just what I mean. So now, where's my marker? So now the distribution bars are placed in this direction. Is that what I mean? The main bars are placed in this direction, while the distribution bars are gonna be placed in this direction. You understand what I mean? Now the main bar distribution, sometimes it can either be on the main bars can either be above or below the distribution bar, but in this case now the distribution bar is gonna be on top of the main bar. So now the main bar is gonna take the length of this side, which is 2400. The distribution bar is gonna take the length of this one. Understand what I mean? So now when I'm calculating the cut length for the main bar distribution bar, this is what I'm referencing. Distribution bar, this is what I'm referencing. So now take a look at the shape. Take a look at the shape of the main bar. You can see that this is the main bar. 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 This is the distribution bar. This little circle there. These are the distribution bars. While this is the main bar. I hope you can all see this. This is the main bar. So now, let us calculate the number of y12 required. So the first thing I'm going to do is I'm going to calculate the cut length for each one. The cut length for the main bar, cut length for distribution bar. So let's go there now. To start calculating, I'm going to do that right now. So now, cut length. Main bar. Enter cut length. I want to use I'm gonna use DIS bar. I can't type the entire distribution, it's gonna take a lot of space. So this bar, and we're there. So now, one thing is also important in this: concrete cover. What is concrete cover? You know, in a typical slab, there is always a concrete cover. What is that concrete cover for? It's a sufficient amount of thickness so as to prevent your reinforcements showing off after casting. What is casting? Just pouring of your concrete inside your prepared mold or whatever. So now, concrete cover are usually placed below the reinforcement so that when you pour your concrete, the reinforcement will not show under. You understand? Because sometimes the reinforcement may be very heavy and it starts bulking and to go under, and it will start showing after you finish casting your concrete. Number one, it's not pleasing aesthetically. It's not pleasing in the eye. Secondly, over time that concrete will start over time the reinforcement will start rusting, and that rusting will cause some structural strength to be lost. So now concrete cover is there to make sure that no part of the reinforcement is exposed. So now concrete cover, now on the question it was given as 50 millimeters. So let me write concrete cover here. It's still going to be very important in this calculation. So this is my concrete cover. Concrete cover is given as 50 millimeters in the question. So I'm going to put 50 here. Millimeters, mm. Conversion, this is going to still be the same thing. So I could just copy this, Control C, and paste it here. Sorry. Okay. Copy, paste. 0.05. This is gonna be in meters. So I cannot put my m here. Enter. Now what's gonna be my cost length for the main bar? Let's go back to that diagram. So now, on the question, read the question with me. The bending on the question was given at 100 millimeters. So now, what's gonna be our cost length? The bending here is 100 mm. The bending here is 100 mm. Now, this reinforcement is supposed to be from this edge to this edge, but there is a concrete cover there. That concrete cover there is to protect the reinforcement, and its thickness is 0.05 m or 50 millimeter. So now what we're going to do, we're going to minus the concrete cover from the total length, then add the bending. Hope you understand. Minus the concrete cover, but add the bending to get the total cut length. So now I want to add 100 plus 100 plus 2400 minus 50 here, 50 here. So let's go to the calculation sheet. So now concrete cover, so cut length for member is not going to be equals to, I didn't also put bending here, sorry, I didn't put bending, escape. So now the bending of the reinforcement, then bending was 100 mm. So I think I can drag every one of these here to get the answer. Nope, not gonna work. Control D. So now I'm going to drag this down, drag this down, drag this down. So now cut length is not going to be my bending plus my bending. Now bending is 2. I can just be like equals to 2 times my bending plus, I put a bracket, plus 2400 minus 2400. 2400 was supposed to be the width, so I'm using this width now. 2400 is the width there, minus 2 times the concrete cover. I close bracket, enter. My cut length is 3001. Are we following? So let me change this back to 6000. Let me change this back to 2400. Enter. Change this to 2.5. Then change this to 150. Cut length is 2500. Do you all understand? So now conversion is still in meters. I could still copy the formula here. I copy the formula here, come here and paste it. 2.5 is going to be in meters. Enter. So I'm basically the cut length for main bar 2500. This is millimeter, sorry, mm. Enter. 2500 millimeter for the cut length. So now we're going to go to find for the distribution bar, cut length for the distribution bar. So now this is the distribution bar. The distribution bar is going to be the same thing. It's going to be the same thing. 100, 100. So we're going to use the same method over there. So now, since they say the bending at both sides, now what they say the bending, it bends at both sides. That means it bends at both the distribution bar and it bends at the main bar as well. So now we're going to use the same method for the distribution bar as well, because the bend, according to the question, it bends at both the distribution bar and it bends at the main bar as well. So I'm going to use the same calculation as well. So it's now going to be equals to 2 times my bending plus my length. I'm going to put a bracket there. My length is 6,000 minus 2 times my concrete cover, and I close the bracket and I press enter. The cut length is 6,100. 6,100. So this is going to still be in mm. So I could come here, copy the formula, come here and paste my formula. 61M. So now I calculated the cut length now. So now this is for only one. Let's go back to the diagram. This is for only one. When I say one, you just calculated the cut length for only one steel member. This is it now. Look at this place here. This particular thing is more than one. This particular main bar reinforcement is more than one. It runs along the entire length. So now we are going to find out how many of that main bar is going to be in that slab. It is more than one. We're going to calculate. We're going to find out how many of that cut length is going to run along that slab. It's for the main bar and distribution bar. So we're going to do that now, and I'm going to call that number. I'm going to call that number.